Okay, so this is a trig equation question, and it's from 2018, so we haven't done a few of these in a while, so rather than just give you one and ask you to try it and maybe seeing a few of you stuck, we'll just look at it here. So find all the values of x for which cos of 2x equals minus root 3 over 2, and you can see that we're working in degrees, so change your calculator to degrees. Now the first thing that you kind of do in these questions, that you might remember the Alfie stole the chickens. So what this means that in this quadrant, sin, cos and tan are positive. In this quadrant, only sin is positive. In this quadrant, only tan is positive. And in this quadrant, only cos is positive. For example, any angle that's in this quadrant here will be between 270 and 360 degrees. So if I went cos 330 degrees, I would expect my answer to be positive. But if I went cos 240 degrees, which would be in here, so say cos 240, I would expect it to be negative, because it's only tan that's positive in that quadrant. Only angles between 180 and 270 for tan are positive there. So the first thing I need to do when I get a question like this, I need to find my reference angle. Now, so cos 2x, forget about the negative sign for a second and just do cos 2x equals root 3 over 2. So 2x equals cos inverse, or cos to the minus 1. Some people have a problem with inverse of that. So shift cos to the minus 1 of root 3 over 2 should give me 30 degrees. So that gives me 30 degrees. Now I'm just going to draw this reference angle here. But I'm looking, where is cos negative? Cos is negative in this quadrant and this quadrant. So I make an angle of 30 degrees there, and I make an angle of 30 degrees there. The reference angle is always made with the x-axis. So what's the size of this angle? Well, it's 150. So 2x equals 150 degrees. Or also, what's the size of that angle? 2x equals 210 degrees. Now, but I'm looking for all solutions between 0 and 360. If you look at this red arrow for a second, if I go around another 360 degrees and I put in, so that's 150. So if I did cos 150 plus 360 degrees, I should get out minus root 3 over 2 again. So there may be more values of x that give me out root 3 over 2. So I have to find them all, and it's the same here. If I added 360 to that, I'll get out minus root 3 over 2. So just keep going. So add, so you've got 150, say, add 360 onto that, and what do you get? You get 510. Now add 360 onto that, you get 870. Now I'll stop there. Now, so there's 210. Add 360 onto that, you get 570. And add 360 onto that, you'll get 930, I hope, yeah. Now divide everything by 2. So x is 75. Divide that by 2 and you get 255. Now if we divide this by 2, we get 435 degrees. But we're told up here we're only interested in solutions between 0 and 360, so that's not a solution. Go over here now and finish it off here. X equals 105 degrees, and then divide this by 2. So that's 225, 235, is it? No, 250, 275 degrees. And then if I divide that by 2, I'll get a number that's greater than 360. So those are my solutions. Now we'll do this one as well. This is a tricky enough little question if you've never seen, or if it's been a while since you've seen it. So let cos A, what's that there now? Cos A equal, oh, there's a bit of a problem with the printer there, so sorry, so I think that's y over 2. Write sin 2a in terms of y. So in this question, you're given that cos A is y over 2. So that will allow you to draw a little right angled triangle. So there's A. Now cos is the adjacent over the hypotenuse, so that's the adjacent y, and that's the hypotenuse. Now we'll call this x. So first of all, what is x? Well, everything is to be done in terms of y, so we're going to use Pythagoras Theorem here to get this. So x squared equals 4 minus y squared. So x equals the square root of 4 minus y. Now we're going to be using some identities here. So, and it's important in these identities, they're in your tables, the trig identities. So we'll have to make use of those. So what is sin A first, for example now? So it might allow, so if that gets you sin A would be equal to, so in terms of y, remember that this is x is 4 minus, sorry, that's y squared. So sin A would be the opposite over the hypotenuse. So I now have sin A and I have cos A, so just to bear in mind from the question, cos A is y over 2. Now we're going to need to find an identity here in your form or in your tables. If any of you can, if you just go now to your tables and look for some identity that has sin A, and hopefully you'll be able to notice in your tables that there's an identity for sin 2a that says 2 sin A cos A. And the reason that we take that one is I know sin A and I know cos A, but more importantly, I know them both in terms of y. So sin 2a equals 2 sin A, and sin A is root 4 minus y squared over 2 times cos A. So cos A is then y over 2. Now this 2 here will divide with that 2. So that just leaves you with root 4 minus y squared times y. So we can just put the y there, all over 2.